So we look at few questions from matrices and determinants, basically determinants. It's the first part of it, okay? Quick revision. These are all past paper questions, so we do them one by one. The first question here, it says, find the equation of the line joining A13 and B00 using determinants. Find the equation of the line joining the 2 points A and B. There are 2 points given to you, A and B, and we need to find out the equation of the line. So what I would suggest is, the first thing is you draw a line. So we're going to draw a line here. So that's the given line. And they said this is passing through the 2 points A, 1, 3, and then there is a point B, which is 0, 0. The question is to find out the equation of this line. So to find the equation of a line, I need a general point on it. So I'm going to mark a general point on this line. Probably extend it a bit more and mark a general point on it. Call it as x, y. So that's a general point P, x, y. So on this line AB, now I have 3 points. P, x, y. Then I have, so that's the first point, P, x, y. Then I have A, 1, 3, B, 0, 0. So when you know 3 points here, how do I get a relation connecting these 3 points? There are different ways of doing it. But since we are asked to do it using determinants, we use the area of a triangle formula. In case these 3 points form a triangle, we know how to find out the area of the triangle. And since these 3 points are on the same line, the points are said to be collinear. And so the area of such a triangle will turn out to be 0, because there is no triangle which you can form by 3 points when they are on the same straight line. So that's what we are going to say. So we'll say, if you try to find out the area of the triangle PAB, the area has to be 0. So I'm going to find the area of the triangle PAB. Area of triangle PAB, since you cannot form a triangle PAB, its area has to be equal to 0. And area of a triangle, we have a formula. When it passes through the 3 points, we call them as x1, y1, the first point, x2, y2, the second point, and x3, y3, the third point. So these are the 3 points, x1, y1, the first point, x2, y2, the second point, and x3, y3, the third point. And then the area of a triangle, we have a formula, half determinant, x1, y1, and 1. Second point, x2, y2, and 1. Third point, x3, y3, and 1 is equal to 0. That's area of the triangle formula. But here, since the 3 points are collinear, since they lie on the same line, area is 0. I can multiply both sides by 2, so the half will go away, or cross multiply 2 to the other side. It will become 0 into 2, which is 0. So I don't have to write half anymore now. So determinant. The first point is x1, y1 is basically xy. So x, y, and 1. Then x2, y2 is 1, 3. So I'm going to write that here, 1, 3, and 1. Then I have the next point, x3, y3, 0, 0. So I'll write 0, 0, and 1. 0, 0, and 1. So x1, y1, 1, x2, y2, 1, and x3, y3, 1. Now we expand it, and when you expand it, normal determinant evaluation. So I write x into its minor. What is the minor of x? Delete the row and the column it belongs to. You can see 4 different numbers that forms its minor. You can do it in your head, or you can show the minor. 3, 1, 0, 1. The next position sign is always subtraction. So minus, we pick up the next element, which is over here. The next element is y. So I write y into its minor. What do I do? Delete the row and the column it belongs to. You can see 4 different numbers. 1, 1, 0, 1. So that's what I'm going to do. So minus y into the minor of y. What's the minor of y again? So delete the row and the column where y belongs to. the 4 different numbers which you see here. 1, 1, 0, 1. So 1, 1, 0, 1. Then I have plus. The next position sign is plus. The element is 1 into its minor. Minor will be the remaining 4 numbers here. 1, 3, 0, 0. So plus 1 into the minor is 1, 3, 0, 0 is equal to 0. Then we try to simplify this. So x into 3 minus 0 minus y into 1 minus 0. How did I do that again? So you cross multiply like that. 3 into 1. Diagonal elements you multiply 3 into 1. And it's always subtraction after that. So first product is 3 into 1. Then subtract. Then 1 into 0 is 0. Here 1 into 1. I wrote 1. Subtract minus 0 into 1. So like that. And then plus 1 into cross multiply like that. 1 into 0 is 0, minus 3 into 0 is 0, is equal to 0. So that gives me 3x minus 1y is equal to 0, is the equation of the line. So we did the first part of the question. But also there is another question there. It says, the second part of the question, what does it say there? Let's see. The second part is, find the value of k if d k comma 0 is a point such that area of triangle ABD is 3 square units. Area of triangle ABD. So I'm going to draw a small triangle ABD. So I have a triangle ABD with vertices A, B, and D. A is 1, 3. B is 0, 0, and D they told you what it is. Look at the question. It says D is K0. So I mark the point D, which is K, 0, and the area of it is, they told you 3 square units. 3 square units. That's the area. And we need to solve for K. So I'm going to start with area. Area is 3 square units. But to find the area of a triangle, we have a formula, so I'm going to use that formula. So when I use the formula, it's going to be half determinant x1, y1, 1, x2, y2, 1, x3, y3, 1 is equal to 3. Area is 3. But the small problem here is we find the area using a determinant. And the determinant value doesn't have to be always positive. Area is positive. That's why they said area is 3. But the determinant could have given you a negative value as well. So it doesn't have to be necessarily positive 3. So which means when I put it as determinant, I can't be sure that it is always 3. It could also be negative 3. So I say plus or minus 3. I will cross multiply 2 to the other side and sub in the values. So any one point can be x1, y1. The second point is x2, y2. And the third point is x3, y3. But since there is an unknown involved here, which is k, 0, I want to choose this as my x1, y1. The unknown point I would always like to keep as my first row. So it's determinant, the unknown point, k, 0, and 1. Then in any order you like, 0, 0, and 1, 1, 3, and 1. So I took B as the second point and A as the third point. It's equal to plus or minus 6 now. So I'm going to expand the determinant now and solve for K. So K into its minor. Now what's the minor of K? So I delete the row and the column it belongs to, cross multiply. 0 into 1 is 0, minus 3. 0 minus 3 minus the second element is 0 here. So I don't have to worry about its minor. It's going to be anyway 0. So plus 1 into its minor. What's the minor of 1? Delete the row and the column it belongs to. Cross multiply 0 minus 0. So I get 0 minus 0 is equal to plus or minus 6. So minus 3k is equal to plus or minus 6. But now you need to do it separately. You will write minus 3k is equal to 6 first and find k, then minus 3k is equal to minus 6 and find k. So minus 3k is equal to 6 or minus 3k is equal to minus 6. So k is equal to minus 2 or k is equal to positive 2. So that's the solution there. Okay, so let's move on to the next question. The question here, this is probably a 1-mark question, yeah? So it's also from a past paper. There is a matrix given to you, then it says write the cofactor of the element A21 of its second row, A21. So let's mark which is A21. A21 means what? This A21 when they say it's the second row first column element, second row first column element. That's this element, second row first column, A21. So I'm going to mark that, highlight that term. That's my A21. They want the cofactor of it. Cofactors are denoted by capital letter, uppercase A. So I'm going to say what I need to find is A21. That's it, A21. Cofactor. So we are trying to find out the cofactor. Cofactor is the signed minor. So you need to have a sign for this. You can probably go back to the matrix and then find out the position sign. This is positive, negative. How does it go? Positive, negative, positive. So negative, positive, negative, positive, negative, and positive. So this is negative. Yeah. So you can just count and take it. Starts with positive. Positive, negative, positive. So negative, positive, negative, positive, negative, and positive. Like that. You can count and get the sign. Or minus 1 to the power of I plus j. That's another rule. So anyway, we know it is minus. It's called signed minor. So there is a minus sign outside. And the minor of which element? A12. Minor of this element means delete the row and the column it belongs to. You can see 4 different numbers now. 6 minus 3. The remaining 4 numbers. 6 minus 3 minus 7, 3. 6 minus 3 minus 7, 3. You could directly multiply also. Minus of, when I cross multiply, 6 into 3, 18, minus 21. That's going to be minus of minus 3, which is 3. So that's the cofactor of A21. 1 more question. Okay. Question 3 here. It's practically the same question. If Aij is the cofactor of Aij, yeah, uppercase A denotes the cofactor. Okay, so of Aij, then write the value of A32 times its cofactor. So you want to find out the cofactor of A32 and multiply it by A32, which means the element. So this lower case is the element and this is the cofactor. So we want to multiply the element and the cofactor together. So let's just do, okay, let's write what is A32 first, which means the element A32. A32 means third row, A32 is the third row, second column element. Third row, second column element. That's this element in this position, which is 5. That's A32. Third row, second column element. Third row, second column is 5. So that is A32. Now I need uppercase A32, which means cofactor. So what's the sign? You can count and take it, or minus 1 to the power of I plus j. That's another way of finding the sign of the position sign. Negative 1 to the power of I plus j. I plus j means 3 plus 2. So minus 1 to the power of 3 plus 2. Minus 1 to the power of 5, which will be minus 1 itself. You could count and get it as well. Plus, minus, plus, minus, plus, minus, plus, minus. Okay, that's what we are looking for. Plus. That's the element we are looking for. A32. So that's negative. Position sign is negative into its minor. Now what's the minor of A32? Delete the row and the column it belongs to. You can see 4 different numbers now. 2, 5, 6, 4. 2, 5, 6, 4. Cross multiply. So that's going to be negative of 8 minus 30, which is negative of negative 22, which is 22. Therefore, what they are asking for is A32 multiplied by A32. Element multiplied by the cofactor. 5 into 22. 110 is the answer. Look at that. Yeah. Question 4. If there is a determinant given to you here, write the minor of the element A23. I think you should try this on your own. Minor of the element A23. Just the minor, not the cofactor. Minor, see the difference. This time they want only the minor. There is no position sign attached. In the previous case, previous two questions, cofactors were involved. So we put a position sign first. Here you won't put the position sign. A23 means what? Second row, third column element. Second row, that's second row, third column. That's this element, A23. The element here, that's A3, A23. Second row, third column element. And what do they want? They just want the minor of it. So what should I do? Delete the row and the column it belongs to. Just write the minor. So the minor is the remaining 4 elements. So that's the element A23. Delete the row, delete the column. 5, 3, 1, 2. 5, 3, 1, 2. Determinant 5, 3, 1, 2 is the minor. Of course, you need to evaluate. So when you evaluate, you will get 10 minus 3, which is 7. See the difference? If it was cofactor, I would have had the position sign outside. And what's the position sign here? Minus 1 to the power of 2 plus 3. So it is negative. Or plus minus plus minus plus minus. So you would have had a minus sign outside here. So minus of that, which is negative 7. That would have been the cofactor. But the question here is not a cofactor. They just want the minor. We did that. Question 5. Find the cofactor of A32. You're going to do that yourself. It's the same question. Look at the question, copy it down. Take two minutes to do it yourself. So write the cofactor of the element A32. You can pause the video and then do that yourself. Okay. Question 6 is to find the minor. Again, so see the difference between 5 and 6. In here, they ask for cofactor. So it's a signed minor. So you'll have a position sign outside attached. This is only the minor. So no position sign. Okay, 5 and 6, you do it yourself. Okay, so question number 7, find the minor of the element of the second row, third column element. A32, A23, A23, second row, third column element, and they want the minor. Of course, you know how to do it, okay? It's repeated in different, like Delhi, the other one was all India. So probably some questions are repeated that way, okay? Question 8 here. If A is a square matrix of order 3. So as you are reading this question, you should collect the information from that. It says it's a square matrix of order 3. So n is equal to 3. Of order 3. Square matrix of order 3. N is equal to 3. And then they say determinant A is equal to 9. The question is to find out the value of determinant of 2 times adjoint of A. Okay, so I'm going to remind you 1 or 2 results which we require for this. The first result is inside a determinant, if you have a number written like this, determinant of lowercase m stands for a number and uppercase a stands for a matrix. So it's determinant of m times a. So we have a number written inside the determinant. If I take the number out of the determinant, whenever the number is taken out of the determinant, it comes out with a power n, where n is the order of the matrix. So this is going to be m to the power of n into determinant A. So when you take a number out of the determinant, it comes out with power n, where n is the order, where n is the order of the matrix, order of matrix. Order of the matrix A. Okay, second result which we need here is determinant of adjoint of A. We have a formula for this. All this you just have to remember the formula. Determinant of adjoint of A is determinant A raised to n minus 1. determinant of adjoint of A is determinant A raised to n minus 1. So this is going to be 2 comes out first as 2 raised to n into determinant of adjoint of A. So in this step, I only took 2 out. So 2 raised to n into determinant of adjoint of A, which is equal to 2 raised to n means here n is 3, so 2 cubed into determinant of adjoint of A is determinant A raised to n minus 1. 2 cubed is 8 into determinant A is 9 raised to n minus 1 is 3 minus 1. 3 minus 1 is 2. So 8 into 81. You need to multiply the 2, that's 8 and 64. That's your answer. Okay. So look at the results we apply. Copy down the results as well. Okay. Question 9. Okay. So here it says if A is a 3 by 3 invertible matrix, so n is equal to 3. It's a 3 by 3 matrix. N is equal to 3. What will be the value of K if determinant of, it says determinant of A inverse is equal to determinant of A to the power of K. It's a 1 mark question. It's just recollecting the result. So I'm going to write the result which we need here. Determinant of A inverse. That's what they are saying. The left-hand side determinant of A. I wrote it like that. Use the symbol. That's it. Determinant of A inverse is equal to 1 by determinant A. That's a result. Determinant of A inverse is 1 by determinant A. So what I'm going to do is I'm going to work on this question. So determinant of A inverse is what I know, 1 by determinant A. I'm writing the way they wrote. They didn't use the symbol for determinant. They wrote DET determinant. So determinant of A inverse is 1 by determinant A is equal to determinant A to the power of K. The right hand side I copied as it is. You see what's happening? But on the left side, can't I write this as determinant of A? It is in the denominator, so can't I say that is equal to the power of minus 1? Anything in the denominator, when I push it up, it becomes with power minus 1 is equal to determinant of A to the power of K. Therefore, K has to be equal to minus 1. It's just knowing the result. Determinant of A inverse is 1 by determinant A. Okay. Question 10. For any 2 by 2 square matrix A into adjoint of A is this. Okay, again, it's all about knowing the result. What is A into adjoint of A? Okay, let's copy what they have given. A into adjoint of A is equal to 8008. But A into adjoint of A, this is the result. I'm going to write the result again for you. So A into adjoint of A is equal to determinant A times I. That's the result. A into adjoint of A is determinant A times I. It's all about knowing these small results. A into adjoint of A is determinant A times I. So on the left side, I will get determinant A times I is equal to 8 into 1001. Can't I write like that? 80, look at that, 8008. I wrote it like 8 times. 1001. I took 8 out. Yeah. So 8 times that, which is equal to, that is same as determinant A into I is equal to 8 into I. 1001 is I. So if you compare the two, don't you get, okay, this and this you remove, it's not cancelling actually. Okay, I into that. So it's just comparing. Determinant A is equal to 8. Therefore, determinant A has to be equal to 8. Again, just knowing the result. Question number 11. Look at this question. It says, in the interval from pi by 2 to pi, it's the open interval, pi by 2 to pi, which means your x can only take values from pi by 2 to pi. What does that mean? Pi by 2 to pi means it's in the second quadrant. That's the meaning of it, yeah? Pi by 2 is here. 0, pi by 2, pi. So you are only talking about angles in this region. That's what they are saying. Second quadrant. Second quadrant. I don't know if it has got a lot of 11s here, but that's the meaning of it. Anyway, I wrote it. Oh, maybe it is because they are asking you to find out the value of x. So x is coming in the second quadrant. That's the meaning. The angle is coming here. So all the way here until here. That's your x. Yeah, in the second quadrant. It's an obtuse angle. X is an obtuse angle, we know, between pi by 2 and pi. Now, what do they say? The given matrix is singular. And now, when do we say a matrix is singular? Okay, this is a singular matrix. When do we say it's singular? If determinant A is equal to 0. You will call a matrix as a singular matrix if determinant A is 0. So, which means whatever matrix given to you here, its determinant has to be equal to 0. So, since it is singular, determinant 2 sin x 3 1 2 sin x has to be equal to 0. So when you cross multiply, you will get 4 sin square x minus 3 is equal to 0. I evaluated the determinant and its value is 0, we know, because it is singular. So I solve for sin square x. 4 sin square x is equal to 3. Therefore, sin square x is equal to 3 by 4. Therefore, sin x is equal to plus or minus root 3 by 2. Taking square root 3 and 4 becomes 2. So there are two cases, sin x is equal to root 3 by 2 or sin x is equal to minus root 3 by 2. But we can see that your x is in the second quadrant. See, don't forget that x is in the second quadrant. And we had this rule, if you remember, all silver tea cups, all ASTC, all silver tea cups after school to college, ASTC. All ratios are positive in the first quadrant, only sine is positive in the second quadrant, only tan is positive in the third quadrant, and only cos is positive in the fourth quadrant. So in the our angle is supposed to be in the second quadrant. They said it's an obtuse angle, second quadrant. So second quadrant, sine is positive. So sine is negative. Negative root 3 by 2 is wrong. That's ruled out. So I'm going to say this is ruled out. Because x is obtuse, it is in the second quadrant. It cannot be negative in the second quadrant. Sine cannot be negative. So sin x is equal to root 3 by 2. How do I find out x? Sine of which angle gives me root 3 by 2? So I know that my little table from class 11. Sine 30 is 1 by 2. Sine 45 is 1 over root 2. Sine 60 is root 3 by 2. So x is 60 degrees. Oh no, they said radians. So pi by 3. 60 degrees is pi by 3 radians. X is pi by 3 radians. Oh no, that's again wrong. Because pi by 3 is smaller than pi by 2. It's in the first quadrant. So we want to make this angle in the second quadrant. How do I bring it into the second quadrant? So I'm talking about pi by 3, which is in the first quadrant. But if I have to get it in the second quadrant, what do I do? If this is pi by 3, this is also pi by 3. So I should go that much back from pi, right? See, from pi, I should move back. Like it is 60 degrees here. Then how do I get it here? 180 degrees minus 60. So I can say the angle out here is this much is 120 degrees. Yeah. So to make it in the second quadrant, you will say pi minus. To make it in the second quadrant, you will say pi. This is pi. From that pi, you go back. Pi minus pi by 3. So 2 pi by 3. I'm just asking, in case I wanted to push this angle to the third quadrant, what would have been the method? Then it would have been pi plus. You add from pi, go to the third quadrant. But here I wanted to go back to the second quadrant. So pi minus pi by 3, which is 2 pi by 3 is the answer. Okay, bit tricky. Okay. Question number 12, find adjoint of A. How do I actually find out the adjoint of A? I do cofactors first. Capital A, 1, 1, capital A, 1, 2, capital A, 2, 1, capital A, 2, 2. So I do the cofactors. I write the cofactor matrix, then take the transpose. We do this when we find the inverse of a matrix always, often with 3 by 3. But this is to find the adjoint of a 2 by 2. We have a shortcut. We can directly write it. Don't have to do the cofactors. Don't have to take its transpose. Nothing. Directly. Adjoint of A has a shortcut. What's the shortcut? You interchange these two elements. Diagonal elements. The diagonal elements are to be interchanged. It's 5 and 3. You make it 3 and 5. Diagonal elements are interchanged. And make the remaining elements with opposite sign. Multiply by a -1 basically. It's positive 7, so you make it -7. You're not doing anything. You're not interchanging the position there. It's only with the diagonal elements. The remaining elements, make it opposite. Make it opposite sign. Yeah. So it's going to be -7 and then -2. So that's what we did. Okay. That's the adjoint shortcut. If A is a square matrix, look at the next one. It says if A is a square matrix of order 3, such that, order 3. So I write immediately n is equal to 3. Determinant of adjoint of A is 64. Determinant of adjoint of A has a formula. Determinant of adjoint of A is determinant A raised to n minus 1. So I use that formula here. So determinant A raised to n minus 1 is 64. Determinant A raised to n minus 1 is 2. 3 minus 2, 64. So determinant A will be plus or minus 8. Yeah. A is an invertible matrix of order 3. N is equal to 3. Determinant A is equal to 5. Find the value of determinant of adjoint of A. Formula: determinant A raised to n minus 1. 5 raised to 3 minus 1. 5 raised to 2, 25. Yeah. Now we have 2-3 questions on this. This is a singular matrix. Find the value of x. All of them are done the same way. Singular matrix means what? Determinant A is equal to 0. So you'll take the determinant of this, cross multiply like that, right? So 4 times 3 minus 2x minus, then multiply those two. 2 times x plus 1, determinant evaluation. Determinant has to be equal to 0. So I'm evaluating the determinant, cross multiply like this. A into D minus B into C. So when you open the bracket, it is 12 minus 8x minus 2x minus 2 is equal to 0. Minus 10x is equal to minus 10. So x is equal to 1. Solving for x. There are 2-3 questions like that. This is pretty simple, the same way. So you're going to cross multiply like that and then minus that. Determinant is equal to 0 and you get your answer. Okay. This is to write the inverse of the given matrix, and we have a shortcut. The shortcut is not to write the inverse. Shortcut is only to find out the adjoint. So what I'm going to do is I'm going to write the formula for A inverse. A inverse is 1 by determinant A into adjoint of A. That's the formula for A inverse. A inverse is 1 by determinant A into adjoint of A. So I need determinant A. So what is determinant A? Determinant A is determinant 2, 5, 1, 3. Cross multiply. 6 minus 5 is equal to 1. That's determinant A. I also need the adjoint of A. Adjoint of A has a shortcut. What's the shortcut? Interchange the diagonal elements. It's 2 and 3 there. Make it 3 and 2. And the remaining element should be multiplied by a minus 1. So 1 becomes -1. Positive 5 becomes -5. So that's adjoint of A. Therefore, your A inverse will be 1 by determinant A into adjoint of A. 1 by determinant A into adjoint of A. So 1 by determinant A is 1 by 1. Into adjoint of A, we just found 3, -5, -1 and 2. 1 by 1, you don't have to necessarily write. You can skip and write only 3, -5, -1 and 2. Which is your A inverse. Okay. Find the value of X for which the given matrix is a singular matrix. So you'll say determinant A is equal to 0. You cross multiply like that and solve for X. Okay. Here it says write A inverse in terms of A. I don't know. We'll try. Your question is not just to find out A inverse, but your answer should involve A in it. Let's try. Okay. So to find out A inverse, anyway, I need determinant A first. Determinant A is determinant 2, 3, 5, -2. Yeah, determinant A. Because the formula is 1 by determinant A into adjoint of A. So I'm taking the determinant, cross multiply. So that's going to be -4 minus 15, which is -19. Now I need the adjoint. So adjoint of A would be the same matrix, but what should I do? We have a rule. Interchange the diagonal elements. Diagonal elements are 2 and -2. These are the diagonal elements, 2 and -2. Interchange the diagonal elements. So interchange them. 2 and -2 will become -2 and 2. Then what do? For the remaining elements, you change the sign. If it is positive, you make it negative. If it is negative, you make it positive. Here they are positive, so I make them into negative. That's adjoint of A. Now we find A inverse. What is A inverse? 1 by determinant A into adjoint of A. So 1 by determinant A is -19 into adjoint of A is -2, -3, -5, 2. This is A inverse. If they had asked for A inverse, I would have stopped here. But here the question is, find A inverse in terms of A. You want A inverse in terms of A, which means your A has to come back here. Do I see some connection between these two? Oh, I do. I just have to remove a minus sign. So I'm going to take a minus sign out of it. So -1 by -19, I took a negative sign out. So since I took a negative sign out, it becomes +2, +3, +5, and -2. So 1 by 19, and the rest of it is nothing but A. Oh, that's why they said find A inverse in terms of A. Yes, I got A inverse in terms of A. 1 by 19 times A. A by 19 is my A inverse. Look at that, yeah? Okay. For what value of X is this matrix singular? Determinant A is equal to 0, yeah? So you take the determinant, cross multiply like that, subtract, yeah? So this into this minus this into this is equal to 0, solve for X. It's the same thing again. This into this minus this into this is equal to 0. Determinant is equal to 0. Same thing again. Cross multiply like that and solve for X, yeah? Determinant is equal to 0. Okay. I think this is the last of singular matrix. So that one I am doing. So what they say is determinant has to be 0 because it is a singular matrix. 2x plus 2. I opened the bracket. 2x, x, and x minus 2 is equal to 0. I just opened the bracket with 2 there. Since they said A is a singular matrix, determinant has to be equal to 0. So I cross multiply. 2x plus 2 into x minus 2 minus 2x into x is equal to 0. Open the bracket. With 2x I multiply both. Then with plus 2 I multiply both. So that's going to give me 2x squared minus 4x plus 2x minus 4 minus 2x squared is equal to 0. I was expecting this to become a quadratic. Luckily, 2x squared and minus 2x squared is cancelling. So you have minus 2x minus 4 is equal to 0. Minus 2x is equal to 4x is equal to minus 2. But the value of x as negative 2. Yeah? Okay. There is n given to you, 3. Determinant A is 7. Find the value of determinant of adjoint of A, which is determinant A raised to n minus 1, 7 raised to 3 minus 1, 7 squared 49. In fact, I don't like this question. I'm going to slightly change this question, okay? This is the answer to it. Suppose this question was, instead of determinant of adjoint of A, it would have been slightly better, right? To find, okay, let's put two questions. One, A times adjoint of A. Find A times adjoint of A. We have a formula for this. A times adjoint of A is determinant A raised to n. See the small change, okay? This is not determinant of adjoint of A. That's what we did. But the question I changed to A times adjoint of A. Determinant of A times adjoint of A. Then the formula is determinant A raised to n minus 1. No, I'm sorry, only n. So determinant of A times adjoint of A will be determinant A, which is 7 raised to n, 3. Or whatever it comes, 3, 4, 3, I think. Also, they could have asked probably A times adjoint of A. No determinant. A times adjoint of A. So that's a matrix. It's not a numerical answer going to be. It's a matrix going to be the answer, yeah? We have a formula for this. A times adjoint of A is determinant A times I. Determinant A is 7. 7 times I, depending on the order of the given matrix. It's 3 by 3. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Of course, you will take 7 inside. So it's going to be 7, 0, 0, 0, 7, 0, 0, 0, 7. Yeah? So different questions, yeah? You should know them. Write the adjoint. We have a shortcut. Interchange the diagonal elements, 3 and 2. And make the other elements opposite sign. So negative 4 and positive 1. Okay, that's the adjoint of this matrix. This is again to find determinant of adjoint of A. Oh, often they say without finding the adjoint. They want the determinant of adjoint of A, but without finding the adjoint itself. Without finding adjoint. We don't want to find out the adjoint because we have a formula. Determinant of adjoint of A is determinant A raised to n minus 1. What is n? N is 2, 2 by 2. What is determinant A? Determinant 3, 1, 2, minus 3. Cross multiply, you will get minus 9, minus 2, which is minus 11. That's determinant A. Therefore, determinant of adjoint of A, we did not find out the adjoint, but still we can do determinant of adjoint of A, which is determinant A raised to n minus 1, minus 11 raised to 2 minus 1, which is minus 11 raised to 1, minus 11 is the answer. Yeah? Good. 27. It's the same question again. Determinant of easier. Determinant of adjoint of A is determinant A raised to n minus 1. Determinant A is 2. N is 2 as well. 2 by 2 matrix. So 2 minus 1. So it is 2. Determinant of A is 2. Determinant of adjoint of A is also 2. Yeah. So that's it for now. And we'll continue with more revision classes. Okay. So this is one part of it. Basically, in this, we only covered determinant, adjoint, all those properties. That's it. Yeah. Okay. Yeah. See you in the next one.